Bon dia. Bon dia. Començarem la sessió d'avui. La primera ponència és a càrrec del senyor Isidro Navarro.
So, we have the professor of architecture from LaSalle who will talk to us about augmented reality technologies. Thank you for inviting me. I'd like to thank the organizers. I had a chance to participate in the Congress in the Emporia's project. This is one of the things I will explain, because I know that tomorrow we'll have a visit and you will have a better chance to understand the project. Now, my presentation will give you an overview of emerging technologies that more or less everybody knows, but they are oriented towards a very specific application, which is our heritage and, above all, the architectural aspects of it. Clearly, our culture and our history, the Mediterranean, which is our framework, has always been characterized by an artistic source of a wonderful quality, as we see on screen by Canaletto. You know that art and painting specifically are a system to represent reality from a very specific point of view, from the author's point of view. But with this leap forward, this technological leap forward, we offer a much more specific experience of the world, a surprising experience. That's what we want. We want to surprise whilst experimenting all of the information that we can offer that is related to the environment in which we live. And therefore, we also contribute we make our contribution to this enormous amount of information that surrounds us. What can augmented reality do for our heritage? I'm going to give you an example, because I reckon that you're all well aware of it. But in this video, which was prepared by a student in his final project at university, in an Italian university, he showed us how we can apply these technologies when they still did not exist. He was quite visionary. So here we find some examples of technologies, some of which you have already been able to see in yesterday's session. This is a project for the conservation of the heritage in one of the Italian provinces, the Lazio. And this student's proposal was based on ideas in which technology could provide a value added to history, to historical heritage. Clearly, the interaction with touch screens is one of the examples that does not surprise us anymore. However, after this, there is another type of example, which is the augmented reality vision based on what we call wearables devices. We can use eyeglasses, to see what surrounds us. This videotape was done when there were no eyeglasses available, so it is a very visionary video. It is it reflects what we start finding nowadays with applications like this one. We can observe our surroundings and obtain information about our heritage in real time. not only data, which is a very important point, I mean the management of these data, and also from a graphic point of view, how we could reconstruct those ruins so that we can start feeling again that experience from a first-person point of view, not with mobile devices like mobile phones or tablets, but to actually see this from a subject's point of view allows us to go beyond. It turns to be an immersion. Today I've brought you some glasses so that you can actually see them. I mean, they are the ones that are being made available in the market. So, which systems right now, which systems are having the greatest impact in terms of collecting all of that information? I'm not going to talk only about augmented reality, but I'm going to talk about anything that's related to it, what we need for this augmented reality to be possible. And in this first part of my presentation, I'm going to talk about which are the institutions, first of all. I'm going to give you an example. And then how can we capture our surroundings? And this capturing of our heritage, this digital recording, I mean, is it possible afterwards to link it up with an experience with wearable devices? So there is a very important chapter, which is the capture about the capturing of all of this information through 3D scanner devices, but knowing about this project, which is the Google Art project, a very significant database about all of the cultural heritage and museum holdings. You can make virtual visits to museums with online visits. You can make a selection of the catalog from different museums all over the world and thus have your own tailor-made visit. I mean, all of this from this portal. I know that I have some time constraints, so I'm going to start speeding up. Another platform, I mean, another way of doing it would be to just photograph it. Google, after launching the Google Maps capturing system with its cars, it started up another project that's incredibly ambitious, which is the World Wonders Project. We reduced other capturing systems, like this very ingenious bicycle system, but we also have other systems with a backpack, with small cars, places where normal cars cannot access. I mean, that normal cars cannot access, but they can be photographed with this or other systems. We shall now see a video where we show how Google is recording this information, and therefore you can visualize it online using this resource, the portal. So this is a portal that exists where we can visit virtually part of the human heritage with visits from our own desktop or PC. It is also true that beforehand we have had to capture all of that information in order to share it. Here we have some examples. Why? One of the most significant points is this one, this question, why? Because that should be kept for the future. I mean, it should be part of our memory. It should remain in our memory. So any of these initiative actions is a valid one for that reason. It also allows us to have a record for heritage refurbishing interventions in case we had to do some refurbishing or some restoration. That's information we have. Some initiative actions. I mean, I could actually give you a very long list that you probably all know. There are some online pages that allow us to visualize real-time visits of some heritage treasures like this one. Here we go. I'm going to go now straight to, we can now visit the Santa Maria Church and observe this project which was carried out by the Castilla-León regional government. So that's another case. Another capturing system is the so-called gigapan photos with an enormous amount of information, so much so that it could allow us to observe unimaginable details, which are reproduced with online photographs. Here, Alex, for the Sagrada Familia Church, made all of the virtual visits. So here we could get closer and we could even see the peak of the pigeon we have on top of the entry gate. I mean, the detail is so fine-tuned, so refined that we could make some zooming in to a few centimeters. That can be seen on the Sagrada Familia webpage .cat. And that's how we get to 3D scanners. The visual modeling lab from the UPC is working on this type of technology, and they are recording all of the architectural heritage of the city of Barcelona. We've also got initiatives of research projects with university students. For example, here in 2013, the Eureka project, during its summoning, it awarded the ZBD. This project wanted to develop a portable device that could scan 3D any place, even if it were an indoor space. It is a bit picturesque, but well, it's an interesting project. It is funny. That's the result. It can actually scan geometries. You just have to stroll about with this device and collect all of the information you need in any place. Therefore, we have come after these projects, like the ones I showed you beforehand from Barcelona, where we need complex scanning devices that are truly expensive, to developing some more affordable devices that allow us to do it in an easier way. This year, Google launched the Tango project. It is a mobile device that allows you to capture 3D our environment. That's the next step. So what's the future of mobile phones? They should help us not only to communicate, but they should also help us to understand our environment with augmented reality. But sometimes, we should be able to interact with our environment somehow, not only by making photos or videos or 360-degree images, but I should be able to put my hand in front of my device, and by selecting an object I have in front of me, I should be able to obtain information about this object without anything else but the interaction. Therefore, one step forward would be this one, i.e. interaction with our environment. Now, these 200 devices like this one were made, and the fortunate ones who have won, they are sharing their experiences in the network, in the social network, about the advantages, the pros and the cons about this type of technology, which in the near future should be made available to everybody. It is composed of two systems, a double camera, I think it is, with infrared, in order to be able to interact, as we see on screen, with our immediate surroundings. Clearly, technology needs to improve, and here we have a clear example with 3D scanners. Up to which level of definition are we able to capture our surrounding space? The Euclidean project with solid scan as a product, it is very surprising, and here you'll be able to see it on screen. The very high level of definition. All of the things you will see on screen is digitally made. The light conditions, the texture condition. Depending on, those of you who are experts in photography, it's very hard to obtain ideal light conditions. And for those of you who are specialized in modeling, there is no better tool than to be able to collect and capture that heritage with this high level of quality down to every millimeter. Next week, we'll be holding the Gaudi International Congress, where some projects will be shown with a similar technology. Truly impressive about Gaudi's heritage. Therefore, this is being done. This is a technology that's being implemented, and it's opening up new doors to our world, I'm missing one. Okay, so which other devices do we have to capture our surroundings? We have cameras that can be displaced remotely with other new devices like quadricopters, and a software that's able to combine it all. Here we have an example. Sorry for showing you this example. This is the so-called quadricopter called Phantom, which combined with a camera allows us to record different point of view with a relatively cheap system. It's quite affordable to reproduce digitally all of the images in a model that's three-dimensional in a very simple way. And beforehand, I said so. If we could actually record all of the great heritage we do have the tools. This is the model with all of the texture quality, and it is applied directly to geometric surface areas. Now, it allows us to access complex places. It is possible, in fact. In fact, the Sagrada Familia has been scanned with this system. And not only tall buildings, but also indoor places, like this refuge. Now, this technology is also being used to collect our underwater heritage. In Paris, a project has been launched to record all of the heritage, all of the remnants left in the Bay of Pearl Harbor, which has been recorded with underwater cameras. And we have similar models made for this type of documents because they are left in our memories, and that's crucial. In an environment like an open space, open outdoor space, they can be conserved. But in underwater spaces, that conservation task is more complex. Now, other tools that you can use yourselves with your mobile devices, with your mobile phones, are tools like this one, Autodesk, where we reproduce figures directly from a sequence of photographs and an online software. We can reproduce this type of geometries. This was done last Tuesday in the Colonial Güell. Anima Lozada, who participated in it, and, well, today, with the structure sensor device, we have brought it here for you today to make a demo where we can capture any object. Let's have a demo. Let's see if it works. This is the device, what we have here. This is a 3D scanner. Now, this very small device with its own adapter allows us to scan any figure. We shall see it now. Let's give it time to be connected. Let's give it some time, and then we will make the demo. So what does this device allow us to do? Let's see. It is true that we need some conditions to make the scanning process possible. In the surroundings, it's going a bit slow. There we go. Now, here you see the effect. This was done this week, this very same week for the Gaudi Congress. And this is the moment we activate the scanning device. You can see how it is capturing in real time the geometry in this point. It goes from recognizing the depth to generating a grid in real time. And after that, we can make this image, this geometry can be translated to a model for augmented reality. Now, the project we already saw of the Panto crater in Saint Clement de Taule, a clear example of how to recover the heritage with real-time information, incredibly complex, with Albert and his team. We thank them really for this project because it has been a lot of work, very impressive. I have no words. I mean, I don't know if you have had a chance to go to Taule and see it directly. I'm not going to show it again because I know it has been explained to you, but it is truly impressive. Now, other projects that we have carried out with the Department of Graphic Expression from the Faculty of Architecture at the University of Barcelona, we have had a chance to intervene in the BCN Reset project, which wants to recover some spaces in the public squares in the old town of Barcelona with ephemeral architecture interventions. But at the same time, we have accessed these so-called totems that we have in each one of these architectural interventions, and we have defined a QR code that allows us to see that space, that square, back in 1714. With a gyroscope, we can actually observe that type of thing. Let's try it out. Okay, let me switch cables here. And here you can see, we can observe, okay, if we were in that very same square back in 1714, how it was, how the square was during those historical times, with the walls and the gate to the old city. I mean, a lot of research work has been carried out for this in order to get all of the information necessary for this type of project. As usual, it is crucial to be rigorous with this type of thing. Fine, and now, all of this information, what do we do with it? We have to show it clearly. I mean, we have, with augmented reality, there are systems like virtual reality, but there are other systems like augmented reality with devices that are portable, like eyeglasses, the ones I've brought for you here. The eyeglasses that, if you didn't know it, they were originally created back in the Middle Ages by the Dominican friar Giordano da Pisa in 1255. But they have been changed slightly, these glasses, and, well, the change is quite a drastic one. But here you have, for example, one of the models. These are the Epson Moverio, a device that has binoculars and allows us to visualize the world 3D. It is actually, it comes together with this device that actually gives it memory applications. It's an Android device that allows us to connect augmented reality applications and to visualize a stereoscopic image of three-dimensional models that we have just captured with these 3D scanning devices. And we can have in front of us, on top of this marker, I had actually prepared it, but if any one of you can try it out, well, afterwards you will have a chance. We can visualize a sculpture captured with a 3D scanning system. So that would be the marker. And with the eyeglasses, we can inspect this three-dimensional model that has been captured and localized on top of an image. Another device are the so-called UV glasses. As opposed to the Epson Moverio, the Google glasses, I mean, there is a clear difference. And the difference is the fact that this is 3D and this is not 3D. Now, what we're concerned about is to be able to observe information, architectural information about our heritage. This allows us to see it three-dimensionally, and this does not allow us to do so. We have also an image with volume, but with a single camera, with a single visor. So the difference is a significant one. But these ones, as opposed to these ones, allow us to communicate. These do not allow to communicate. This is a phone that's connected to a mobile, and it allows us to communicate with the outside world. And these do not allow us to do that. It is a bidirectional system. Therefore, I can obtain through the internet information, or I can actually call, or I can make a video call and send. I can actually send in real time the vision of a space that I'm actually exploring, a excavation site, a tall building where I cannot bring 50 people with me because only one person can actually access it, and I can transfer it in real time as a video conference what I'm exploring. And this is an experience that in the past it was very hard to do. You could say, well, fine, but you could use a camera. You could use a normal camera, right? You could go use a GoPro or any one of those. Sure. But a GoPro does not allow me to have interaction. But with Google Glasses, I can actually have an interaction with the audience that's observing together with me that place. They can call me up, they can ask me questions, I can answer them. There is an interaction that makes the whole experience a more interesting one. So there is a big difference with this type of devices and other devices, and I'm sure there will be more coming to the market. Vuzix, Optinvent, Record, many are coming out, and there is one that's about to come out, and it's a very interesting one. It's very similar to the Epson, which is, they make a quantum leap forward. They are the so-called meta glasses. It's like this, glasses, with a movement sensor, like this one. They have a movement sensor here on top. I have one. I don't know if it's going to hold. Can you imagine? Now, this movement device, which is a so-called lip mission, it's for computers. We would connect it to the computer, and with our hands, we could interact with three-dimensional elements or with our PC as you wish. But now there will be an eyeglass model that will be coming out soon, and it will have that incorporated in it. And this would allow us, with our own hands, which are in front of us, we could interact with our virtual surroundings. It is another quantum leap forward, a very interesting one indeed. More technologies. These are not augmented reality technologies. They are virtual reality technologies. This I'm holding, these are the Oculus Rift. As you can see, they need wires. It is a pair of glasses that have two screens, and these two screens allow us to have a full immersion in a virtual scene. Can you imagine? Can you imagine an IMAX, a type of image like this one, in which I can actually see the Rome's Pantheon whilst sitting here, and observe all of Rome's Pantheon directly with these eyeglasses? Let me see if I can actually wear them. I could be sitting down with an audio system, with a sound system, and observe this very same space from any place in the world. Okay? Now, if to this object I add a movement sensor like the one I have here in front, I could interact with this virtual world I have in front. All of this software already exists. In fact, there is an accessory to connect deep motion to the glasses. Now, what are we looking for? As you can observe, what we want is to visualize beyond the real world. But we need interaction, because if not, that real world will not give us, or it will not allow us to participate. And it is here where we're making headway with these technologies, with an interaction towards these virtual worlds. So what do they allow us to do? In these screens, we have information, geolocalized information. In this case, Professor Marvin Lingers from the University of Canterbury, with his research group, they reproduced the historical landmarks, the historical buildings in the Sydney city centre, where they have carried out some industrial interventions, and we could observe how that space was some time ago with the Google glasses. Another application like Field Trip, it allows us to see, to have warnings. If we are strolling about the city, there is a little bell that tells us. I turn around and it tells me that you have this here, you have this building. You keep on walking without doing anything, cling, and we have different warnings as you interact with the city. Now, this application does exist for mobile devices and for tablets, for mobile phones, but it's a bit uncomfortable. If you're, for example, if your hands are being used and you're walking around the city, it is a bit uncomfortable. A pair of eyeglasses would allow us to just turn around and watch that information. Translation. In real time translation, the World Lens, the app for translation, you can also observe it firsthand. We could observe it here, and we could ask it to translate. If we had, the application does exist, and we could do it firsthand here. We could use this app for it to translate for us. When we're visiting a museum or an exhibition space, we can go through the artworks and stop in front of them and observe the information and see here the translation online in real time. This would allow us to have sometimes a lot of unnecessary information. We have this real-time translation. At Mosguide, we had a chance to intervene in an augmented reality intervention at the Tapias Foundation, where whilst observing a piece of work, we had related information available. We have the experience of other applications like Guidigo, an app for museums, where a lot of catalog information is being recorded, and the glasses allow us to carry out two types of interactions. One interaction, which is the visit. It tells me what's the visit. If I want to visit the Louvre Museum, what's the itinerary for the Egyptian department? For example, it tells me the distance where I have to head to, and when I find an artwork, I place myself in front of it, I scan it, and it tells me, with audio guide, it gives me information about that artwork without using normal glasses. I can have multimedia information, videos, etc. In this presentation, which we will share with you, you can have the links where everything is explained. And finally, the Emporius project, where we participated with a group of students from the Polytechnic University. A group of 20 students made a stage, a practice of 20 days. We reconstructed cement buildings, And in addition to that, we have a geolocalized path with a geolaser of these buildings that we can actually observe from with the Google glasses. I'm going to show you this video because it's the last one. And I'll show you how one of these students tries the functionality of this application. We have scanned a QR. We have opened an application about Emporias. So now I touch 0 on the screen, and it tells me what you have at every point. Now this image, which is what's being shown in the glasses projector. The amphitheater. And as we walk, okay, so now I'm going to touch the southern, I'm going to go to the southern sector. And I think it says here, 1st or 2nd century before Christ, or 2nd year before Christ. And okay, so now I have to walk over there. So the navigator becomes activated in order to be able to find the specific point she's looking for. And everything comes up on the screen. You do not need the phone. The phone can be, I mean, here on screen you see the arrow that says straight 50 meters to the left. When you get there, you can see a video or an audio, and all of it without needing to use the phone. So, if you want, here you have a path for the Congress that I prepared for you with some interesting points here in the city center. And if you want to use it with glasses, it works. Beforehand, we came to this building with the glasses, and it worked out. I couldn't find the building, and I thought, well, I'm lost. I have a solution in my hand. Thank you very much indeed.
Algú té alguna pregunta?
Are there any questions?
Perdó.
Gràcies per la presentació. Has introduït...
You have introduced a number of recognition sensors and 3D reading for indoors and outdoors options. What are the best? Still the complex prototypes, those having a more comprehensive technology at user level. You mean with optimum quality? I would keep this one. I would choose this one. This is the device generating all the geometry and generating also all the texture. Structure sensor.
No, wait, that's a camera to capture. It's a codec camera, I believe. It's a codec model for professionals, yeah. And, well, the cost has nothing to do with it. This costs €500, and that one, yeah, you can buy it online. The rest could cost, from 20,000 up. Hi. Now, if you use glasses, how can you use these other glasses? Right, for example, these ones, they have this system, which is a flexible one, and they can be. You take out your glasses, and then you connect them again. I mean, you put them on again, and here you have. I mean, you take out all of this part here, and with an accessory, with this, I mean, this frame, you can take the frame to the eye doctor, so that you can actually substitute it. There's a Catalan company that has actually made a project for this type of accessories. Oh, thank you.
Si voleu veure tot aquest material que se us ha presentat, l'Isidre...
If you want to see all of the material that has been presented, Isidro will be at the pilots area for you to try them out, okay?